Hello, my name is Matt Kiefer. I'm the Enclosed Drive Sales Manager for Cincinnati Gearing Systems. Welcome to our trade show.
And let's check out this gearbox. We have a single stage, double helix, star epicyclic gearbox used for the fracking industry. And on this side, we'll have a gas turbine connected to the input side at 16,000 RPM. And on the output side, we'll have the fracking gearbox at 1,500 RPM at a horsepower of 5,500.
This epicyclic gearbox is located in some of the harshest environments in the oil and gas industry. The epicyclic gear unit inherent compact design saves space on the customer's package, has a heavy-duty life cycle, and low maintenance requirements simplify and minimize field downtime. Similar in design to the fracking unit, the generator gear unit is also single-stage, double helix, star epicyclic. It will be driven with a gas turbine driving a 50 or 60 Hertz generator. The 50 Hertz unit has a ratio of 10.667 to 1, and the 60 Hertz an 8.827 to 1 ratio. At 60 Hertz, the input speed is 15,890 RPM, output is 1,800 RPM, and at 50 Hertz, the input speed is 16,000 RPM, output speed is 1,500 RPM. Typical horsepower for this application is about 6,000 horsepower.
Hi, I'm Patrick Potter, Director of Sales at Cincinnati Gearing Systems. So our SP17 single pinion integral gearbox has been specifically designed for an expander to generator application. It's being used for an air separation process and power recovery. So this is our SP14 single pinion integral gear unit. It's designed for pinion speeds from about 15,000 to 65,000 RPM. We typically use a Hearth connection, which is very good for balance repeatability and for assembly. Customers tend to prefer that. We have a unique and proprietary high-speed thrust bearing design, which is contained in this housing. It's designed for optimal efficiency, minimum power loss, and oil flow. So it minimizes the axial movement of the pinion and is very much in accordance with the latest API 617 standards. We recently completed a split power path design for a gas turbine manufacturer with a pinion speed of 74,000 RPM.
I'm Eddie Brooks, Director of Design Engineering at Cincinnati Gearing Systems. This is an example of one of our custom design gearboxes that was made for a generator application. The unique design challenges of this gearbox was the high input speed. The input pinion was totally supported by the customer's turbine, eliminating the need for any high-speed input bearings, and then actually flange mounted to the generator in the back. The input speed on this was nearly 75,000 RPM with an output speed of 1,800 RPM, roughly a 47.5 to 1 ratio.
Cincinnati Gearing has the ability to work with our customers. Whether it's a clean sheet design or standard design, we will draw from our over 110 years of gearing expertise to provide you the drive you require.
Hi, I'm Patrick Potter, Director of Sales at Cincinnati Gearing Systems. If you have a high-speed or a high-power application, our engineering team is ready with the latest technology to find the right solution for your job. Another constant at Cincinnati Gearing Systems is our commitment to innovation. Our engineering and management teams are both active participants in AGMA and API and are working hard to develop new techniques to meet the ever-increasing power and speed requirements of our customers. At the same time, we're working to improve existing design and manufacturing techniques to build even more reliability into today's turbomachinery gear units. We are very excited to have been a part of the development of API 677 4th edition, which will cover epicyclic gearboxes in detail and is set for publication later this year. Cincinnati Gearing Systems has developed custom engineered designs to meet the requirements of the following applications: API 617 integrally geared machines, both single and multi-pinion, double helical standalone gearboxes for gas turbine to generator and electric motor to compressor drives, epicyclic gearboxes for frac pumping and gensets, microturbine gearboxes, marine propulsion drives for both military and commercial high-speed ferries, and many more. This is Cincinnati Gearing Systems MA107 family of marine drive gearboxes. These gearboxes are designed to accept a 6,000 horsepower gas turbine and take power out to a water jet on the other side. They're also modular in design, which means the gas turbine can be mounted in this direction or the opposite direction, and the output shaft to the water jet can either be towards the front or towards the rear. This gearbox also includes an integrated oil sump, which is actually below this plate here, which simulates the deck level of the ship's mounting structure. Towards the back of the gearbox also includes an integrated PTO pad at the rear. This particular PTO shows 2 mounting pads. We also have an option for 4 mounting pads to add to the number of accessories you can include. Right now we're showing the mechanical lube oil pump, and this supplies lube oil to both the gearbox and the turbine. We recently completed a split power path design for a gas turbine manufacturer with a pinion speed of 74,000 RPM, which uses a low helix angle, single helical gear system, which is low in noise and very high in efficiency. It's essentially an epicyclic gearbox without a ring gear.
I'm Eddie Brooks, Director of Design Engineering at Cincinnati Gearing Systems. Cincinnati Gearing Systems, we have an in-house design engineering department that is available to completely design a white sheet design or engineer existing designs to assist in rebuild, re-rate, or modifications to pretty much any manufacturer's existing gearboxes. Our range of experiences in the department ranges everywhere from a 40-plus year chief engineer down to a very active co-op department.